Good afternoon once again, fellow scholars. It is I, Chris Crowe, and tonight we are going to be learning some Module 5 skills. This is going to be Chapter 7. Now, without any further ado, let us hop into tonight's lesson. Now, if you'll take a look at my PowerPoint, as you can see here, Module 5, Chapter 7, and moving on to our first question, you're going to be presented with a number. Now we're going to put this x equals the number. In this case, it's 0.225. Now, our goal is to change this number into a fraction in its simplest form. Well, how do we do that? Well, there's one major method. There's two ways to get to that method. I'll explain both of them. So the first one is, you see this little point right here in the middle between 0 and 2. That's what we call the decimal point. And now with the decimal point, you're going to want to move that over any amount of space necessary until you get past the final digit of the number. So in this case, we had to move it 3 spaces to the right after 5, which gives us 225. Now you can simply move the decimal point, or you can do the decimal number multiplied by, in this case, 1,000. And why is it 1,000? Well, because, as I showed before, you have to move the decimal point 3 spaces. And so 1,000 with its 3 zeros is the appropriate number. If you had to move it 2 spaces, it would be 100. If you had to move it 1, it would be simply 10. If you had to move it 5, it would be, 100,000. So once you have 225, you're going to take that number and you're going to equal it to 1000x. And the next step after that is to subtract the x from the 1000x. So then you're left with 999x equals 225. Once you have that, you have to divide both sides by 999. So that crosses out these two. And once you divide 225 by 999, you'll get your answer fraction of 9/40. Pretty simple when put into perspective. And we're going to repeat this example with x equals 0.036. Now you might be a bit confused or worried because now there's only 3 and 6, which are the actual numbers, but the same concept will apply itself. You take the decimal point and you move it however many spaces necessary to get past the final digit. In this case, we still, once again, had to move it 3 spaces. So that's going to give us 36. Once again, you can also multiply it by, in this case, 1000, which will give you 36. So once we have that, it's pretty much repeating the same method. You take 36, you equal it to 1000x, you subtract the x from 1000, you're left with 999x equals 36, and then you bring them both down, divide both sides by 999, these cross out, and that's supposed to say 999, but the purpose is to equal the answer fraction of 9/250. And to find out those answers, you can either use your super advanced calculator, or you can simply divide both the numerator and the denominator by the largest multiples necessary until they can be broken down no longer. And in case you're curious, the numerator means the number on the top side of the fraction, and the denominator means the number on the bottom side of the fraction. And once again, once the fraction cannot be broken down anymore, you have reached its simplest form. Now, moving on to our next question, here we see a graph with 1 to 10 on the bottom. We have an equation, which is y equals x/2. And then we have a little word prompt. Humans may double their endurance compared to the average by sticking to a healthy diet and exercising regularly. Now, the whole purpose of this question is we have to label, of sorts, the graph with the expression x over 2. Now, it's fairly simple because obviously the y line is the vertical line. It's the one on the left going up and down. That's what vertical means. And horizontal, the x line, is the one going across from left to right. So, well, we have which lines are which, and it's simply rising by 2, the x over the 2. So it's going to be a small incline like this going over to 2. And once again, if you check the word prompt, you see the word double, which means 2. Now, moving on to our second graph, it's going to be laid out the same way. The numbers will be on top, and you'll see why in a second. Now we have y equals negative x over 2. So the absolute opposite of the one previous. And we have the word prompt, humans cut the risk of heart attack by half simply by reducing the amount of fatty foods they intake. Now, as I showed you before, the x over the 2 means that the line, which represents in this case, it's going to represent the risk of heart attack being cut in half. Now, since it's a negative, it's not going to be upwards, it's going to be going downwards, which is where all of the negatives numbers are going to lie on a line graph. And since it's x over 2, simply with a negative, it's going to go down, leading over to 2. Moving on to the third graph, we see it's set up in the same fashion, but now we have y equals 10x with our word prompt. The decimal system we use on a day-to-day basis is counting in numbers of 10 through each term. Now, terms will be implemented in different numbers, such as the first problem we went over. Every point after the decimal point, every space, has a different name. So instead of the ones, the tens, the hundreds, the thousands, it's going to start off with the tenths, the hundredths, the thousands, and so on and so forth. But here, our equation is y equals 10x. Now, 10x by itself typically means multiplication. So instead of simply going up by a certain amount, instead of going over a certain amount, going up a small incline, we're going to place all of our numbers, and it's going to instead shoot upwards. And you're going to see that it's by 10 both on the vertical and the horizontal lines, the x and the y axes of this graph. That's what multiplication will do for you in this particular instance. Now, our final graph, as you can see, it's still laid out the same way, is going to be y equals x squared. And our prompt, the curved increase of the human population is rising twice as much as it once was. Now, y equals x squared. Well, what is squared? Well, that is simply saying that x is going to be multiplied by itself however many times needed. So in this case, x squared is going to mean x times x. So once again, we're going to place our numbers on the graph. Now, notice it said curved increase of the human population is rising twice as much, twice because of the squared. So the increase is going to curve a certain amount. It's going to start at, let's say, point A. It's going to curve downwards, and then it's going to shoot upwards because squared is an increase. It's an exponent. It's a positive exponent. Negative exponents also exist, but we won't be paying attention to those right now. So, as you can see, we're going to curve and shoot upwards. You can see it starts at 2, it curves downwards, and it shoots all the way back up. Now it's at 10, but if you look down at the x-axis, you can see the line stops above 2. Now, we're going to move on to our third question. And this one, you can see here, is a square. But that's not the only piece that we're going to have to think about. Now, this square right here is going to be divided into 4 equal-sized triangular pieces. And then one of them is going to be split in half and shaded. Now, the purpose of this question is, what is the fraction displayed here, and how exactly can we show that as a percentage? Well, the method is actually quite simple, despite the possible panicking you might be experiencing. So right here, usually if you would say maybe see one of the full triangles shaded in, you would say, okay, that's 1/4, because there's one triangle shaded in out of the total 4, and 1/4 is 25%. But half of the triangle is shaded, so now we're left with a bit of conundrum. But luckily, we know how to do this. So since only half of one triangle is shaded, you'll half all of the equal pieces. Now this will only work with equal size pieces. If they're unequal, then you're going to have a harder time finding out a percentage, if at all. Now since one triangle has been halved, we're going to imagine that all 3 triangles have equal sized halved pieces. And then once we have the full amount of halved pieces, we're going to count them all, 8 in total, and then we'll take a look at how many are shaded. Since 1 is shaded, the fraction is 1/8. And then to find out 1/8 as a percentage, we're going to multiply it by 100, which brings it down to 12.5%. So that one shaded region is 12.5% of the whole. Now moving on to our next shape, we see that there are, once again, all equal sized squares. And there's 9 in total, 3 by 3. And now we're going to shade in 1, 2, 3, and a half squares of the total shape. Now, if you were paying attention, we're going to tackle this one the same way we tackled the last one. If it were just 3 full squares, we could say, okay, that's 3 out of the 9, and we can simply figure out the percentage from there. But since we have the half, we're going to cut all of the squares into equal halved pieces, which is going to equal 18 in total. And since all of them are cut in half, we'll simply count the amount that have been shaded. So 3 of them will equal 1, 2, 3, 4, 5, 6, and then the final halved piece is 7, so 7/18. Once again, we're going to multiply that by 100, which yields the answer 38.8%. So the shaded region of this overall shape is 38.8%. Moving on to our final shape, we see a circle, and now it's been turned into sort of a yin and yang type symbol. Now we can see here it's a bit more difficult, at least at first glance, because, well, there's no real defined shape. It's curved. It's a yin and yang, basically. But if you're looking closely, you can see that the halves are largely the same on both sides. That's 1/2. So we have the actual fraction 1/2. And we're going to multiply that by 100, but you should know by now that 1/2 is 50%. So the blue shaded region of the whole circle is 50%. Now, moving on to our next question, you see a hexagon here. This hexagon is going to represent the whole, and you'll see what that means in a minute. So we have a series of repeat hexagons, and each one of them are going to be filled in with a different shape. A trapezoid, a square, a rhombus, a smaller tan rhombus, and finally a triangle. Now the purpose of this question is we need to discover which shapes represent the percents that are given from the whole. Now this one can largely be figured out by shape size orientation. So if you're well aware, a trapezoid is half of the hexagon, so we can eliminate the 50% almost immediately. Now you might think, well, rhombus is a large shape and it makes up most of a trapezoid, but you would be wrong to think that it's the next largest one simply because it makes up a large majority of the trapezoid. If you're paying attention to the previous hexagons, you see that it only makes up a certain amount of the total whole. But the square, on the other hand, makes up a larger area space than what you might believe. The square itself is actually the second largest percentage. Now remember, you're thinking in percentages, not in simple area take-up space. However, the next largest shape and the next largest percentage is going to be the blue rhombus, because it is the third largest shape in percentages. So we're going to cross that out. Now you might think that, well, the next one has to be the green triangle because that's the largest shape out of all the ones shown. Again, you would be incorrect. If you're once again paying attention, the triangle only takes up a certain amount of the hexagon whole, and two triangles form the blue rhombus. However, that means it's got to be one of the smallest percentage amounts. So if it's not the triangle, it has to be the tan rhombus, followed by the green triangle, as the final percentage amount. This one can largely be figured out by guess and check methods or simply deductive reasonings. Now, number 5 is more of a word problem than the one stated previously. Here we see the prompt. Alyssa has 6 tacos and gives her friend Michael 3 of them. What percentage of the tacos were given to Michael? So we have our numbers, we have our names, and we have our given number. So we have 6 tacos total, Alyssa's tacos. She gives 3 of them to Michael. So half of 6 is 3, so she gives half of them to Michael. So she gives him 3. Now what percentage of the tacos were given to Michael? Now he was given 3 of the total 6. Once again, 3 is half of 6. So if Michael was given half of the tacos, he had to have been given 50% of the tacos. If you're thinking of the 6 as a whole, kind of like the hexagon was. Moving on to our second part of this question. Alyssa has 6 tacos. Her friend Michael asks her to give him 33% of the tacos. How many of the tacos does Alyssa give to Michael? Now we're given Alyssa once again has 6 tacos, but this time Michael asks her a percentage of the tacos rather than a specific amount. So once again, so this time we're going to frame the question as 33% of the 6 tacos equals what? Well, to figure that out, we're going to do 0.33, and why are we doing that instead of the 33%? Well, like I said previously, with the decimal point. 33% doesn't have a decimal point, as you can see, but if you're to imagine a decimal point on the right side of the second 3, and you scoot it over in front of the first 3, you're given 0.33, which is 33% in decimal form. So we'll do 0.33 times 6, the total number of tacos, which gives us 1.98. Now, it's kind of difficult to give someone 1.98 of a taco. So Alyssa has given Michael 2 tacos. If you're going to, and the way you figure out 2 is simply by rounding. So you see the 1 next to you see the 9 next to the 1, you simply round to the 9, and you'll get 2. Now, the third part of this question, Alyssa gave Michael 66% of her tacos. Michael received 4 of the total number of tacos Alyssa had. How many tacos did Alyssa originally have? Now, Michael has been given 66% of the tacos, and it tells you that 66% is 4. So now we need to figure out how many tacos Alyssa originally had. So we have the 4 tacos Michael has received, which equals the 66%. But what is 66% of? Well, to figure that out, we're going to follow the similar method of the previous question, but instead of multiplying, we're going to divide. And like I said before, 66% is turned into 0.66 in decimal form. So we're going to divide 4 by 0.66, which gives us 6 tacos total. Now you might have known that from the previous question, but never ever assume you know the answer because the numbers can easily be changed up on you. Alyssa could have had 20 tacos and simply given Michael 4, as selfish as that would have been. So never assume you have the correct answer. Use your critical thinking, use your deductive reasoning, use your mathematical skills to figure it out. Now, the final question is by far the wordiest one we've had to deal with. A peanut butter chocolate cookie is made from a Reese's lava cube, molding the dough over the cube and baking the cookie like normal. The recipe for the cube is, that should say 2 Reese's peanut butter cups, 2 tablespoons of heavy cream, and any amount of cookie dough. To make the cube, you place the Reese's into a measuring cup, pour the cream, microwave on high for 1 minute, then stir. All that's left to do is freeze the ganache for 1 hour, mold into the dough, bake at 350, and you've got a delicious treat to enjoy. I might try that after this lesson, you never know. So now we have to put down a table outlaying the ratios of the different amounts that were given from the word problem, the different proportions, if you'll call them. So here we're given the table, and we have the servings of 1, 4, 6, and 8, representing, let's say, the amount of cookies we're trying to make. So, like I said, it should have said 2 in the word problem. I apologize for that. But we have 1, 4, 6, and 8 servings, and obviously the number of Reese's cups per cookie is 2. So every time the cookie amount increases, we need to increase the number of Reese's peanut butter cups. And if you notice, every increase of serving is multiplied by 2, because 2 cups need to be added for every cookie made. So if you're trying to make 1 cookie, you need the 2 Reese's peanut butter cups. If you're trying to make 4, you need to multiply the number of cups by the amount of cookies you're trying to make. So 4 cookies will require 8 Reese's peanut butter cups. 6 will require 12, and 8 will require 16. Now, the tablespoons of heavy cream are exact intervals of 2. For every single cookie made, you have to add tablespoons of heavy cream, 2 specifically. And each serving will simply increase by 2. It's not affected by the number of Reese's peanut butter cups or the servings. You just increase them by 2 and you've got your ganache to freeze. Now, we also need to create a graph, a table graph, to show off the increased amounts. And here we are given those amounts. And if you look carefully, they are matched up with their number of servings, the Reese's peanut butter cup amount, and the tablespoon cream. Each one slowly increasing. The number of Reese's cups drastically increases over the span of the serving increase, and the heavy cream simply increases by its increments of 2. And that is the end of our lesson. Now, I hope you guys enjoyed. I know I did. I'm definitely going to try that lava cube recipe. And if you guys have any questions, once again, feel free to let me know. I hope you guys learned something tonight. I know I did. And without further ado, I will see you guys in the next lesson. Have a good night.
I love it when you call me señorita.
Oh God.